Hello everyone, and welcome to today's webinar. My name is Jonathan Spence-Jones, specialist writer with Enlit, and your moderator for the discussion today, which is brought to you in partnership with the ADD Group. And it's my pleasure to introduce our panel today, Ruslan Kasiko, Head of Sales and Marketing for the ADD Group, and Maxime Granatieri, Head of R&D for the ADD Group. During the session, we'd like to hear from you any questions, any queries. And we encourage you to send those through to the panel for live response during the discussion. And you do that through the box on the right-hand side of your screen. We'll attempt to respond to as many of the questions as time allows. And I can also mention the webinar will be available on demand after the live session on the Enlit World website. So to kick off, I'd like to ask Ruslan to give an introduction to the issues and the industry challenges. Ruslan.
Thank you, Jonathan. So do I have the control? Yep. Good afternoon, ladies and gentlemen. We would like to welcome you to our webinar. Today, we want to present you our thoughts and vision, as well as get your feedback as to how to improve the water supply industry, how to make it more efficient, more friendly towards the environment and towards the society. Before we start, I would like to give a quick background of our company. ADD Group is a very well-known smart metering brand in the industry. We are present in business for 33 years. We have delivered, as of today, almost 9 million meters to 38 countries, and we don't stop on that. So we are expanding our geographical presence. Most of our time in the history, we were focused on the smart metering, only allocating all our resources and skills to design and manufacture benchmarking smart metering solutions. And just for you to see, this is our product portfolio. We have smart electricity meters, smart water meters, and sub-metering solution for hotels and rental property. Our key to success comes not only from the large and long background in the smart metering industry in design and manufacturing, but also from our talks to utilities, to other industry experts in order to get an in-depth understanding of the key concerns and the issues that are faced by the industry, by utilities, by regulator, and which are very often not even reflected in the technical specifications. Based on these discussions and learning, we have identified a few key concerns that we are going to highlight during today's webinar. This is water scarcity, meter autonomy, and meter connectivity. Speaking about water scarcity, as of today, there is about 40% of the population that has a limited access to the clean water. And researchers say and forecast that by 2050, the situation will be even worse, and 2/3 of the population will have limited access to the clean water. The key drivers are definitely the climate change and human influence over the scarce water resource. And when we refer to the climate change, there is hardly anything we can really do about that or reverse this climate change. But as to the human influence, we definitely have all the power in our hands to change our behavior to the water consumption, make it more reasonable, treat the non-revenue water in a different way. And here the metering industry has to design and propose to the industry, to the water supply industry, the necessary tools and instruments to make these changes happen. The second concern is the water meter autonomy. For the last couple of years, we have seen a dramatic change in the requirements to water meter life and to battery life specifically. And if only we look at, let's say, 2-3 years or maybe 4 years ago, there was a standard warranty requirement, 24 months for the meter and for the battery itself. Now we see that utilities are already demanding 10 years warranty, 13 years warranty, and even separate warranty for the meter and separate warranty for the battery. But warranty is more or less a commercial term, so it imposes on the vendor the liability to provide a new meter instead of the one where the battery has been discharged. And this doesn't really solve certain technical issues and factors which are influencing the meter life and which are not in the control of the vendor. And basically, when we talk about this specific issues that influence the meter life, we would be talking about extreme high or low temperatures, for example, exposure of the meter to direct sunlight. This could be also the low coverage or loss of connection, loss of connectivity for the meter when the meter tries to makes different attempts to register with the network, to send or resend the messages, to use the maximum power output of the modem, and all this leads to the faster discharge of the battery. Utilities from year to year also demand from the meters more functionality, which leads to more data volume that needs to be retrieved from the meter, and sometimes it leads to more frequent readouts. This definitely also influences the battery life. Besides that, there could be other factors like unpredictable long storage of the meters at the warehouse of the vendor, the warehouse of the utilities. So what do we do in case the battery discharges faster, or what the utility has to do in case the battery discharges faster? Basically, they need to buy a new meter. This is a cost, and they have to pay for installation or for the replacement of the meters, which is also a costly thing. In some countries, it might be such cost might be bigger than the cost of the hardware itself. And finally, last but not the least, key issue is water meter connectivity. So without communication, meters is certainly a dumb device, and it's not worth the cost of it. So many utilities are taking time, making pilots and trials and so on to select from the available communication technologies, which the most known to us are LoRaWAN and BIoT. Wireless and bus, MIoT. Some utilities go beyond that and create their own communication standards, like WISE, for example. However, none of these technologies is perfect. None of these technologies is able to address 100% of infrastructural diversity and to assure 100% of the coverage. And what utilities have to do after the installation, basically they have this communication gaps, and they have to struggle how to remove these gaps and to use the walk by or drive by solutions. But walk by and drive by is not AMI, not smart metering, just simple AMR. And definitely this is not the scope of the smart metering to have readouts just once per month. ADD Group is coming up with the evolution of the water metering with its new ADRA water meter, where with one meter we are able to address the 3 issues: water scarcity, meter lifetime, and connectivity. And after a short break for the poll, I'm pleased to pass the floor to my colleague Maxim Granatyr, who is the head of our R&D, and he is going to provide you the details about our smart metering solution.
Okay, good. Well, thank you, Ruslan. And we're going to have a quick poll now, just to get some feedback from you, the audience. And the question is, what option provided by a shut-off valve would you use to deal with consumers who overuse or do not pay for water? And please select one of these: full water stop, flow limitation, daily consumption limitation, monthly consumption limitation. And there's 1 minute to vote, down to about 35 seconds now. And while you're doing that, let me remind you, please, if you have any questions for the panel, to submit them in the box on the right. And then we'll get to as many of them as we can. Okay, down to 10 seconds now. Okay, that's closed now. Okay, let me also hand over to Maxim, and if you'd also like to comment on the feedback there, Maxim.
Thank you very much, Jonathan, for your managing of a poll. The results of the poll are really, let's say, coming together with our understanding of the needs of wealth, what is used inside of our meters, and it's bringing us to some reasonable understanding that our direction of using of the wealth is quite right. Thank you for this, but of course we still will need to evaluate the poll results, as we will be able to make more adaptable solutions just in the terms of configuration. Once again, Ruslan, thank you very much for your introduction and first part of our presentation today. It's very important for us, as everybody will understand who we are and what we are doing. I will just briefly introduce a little bit about the evolution, because for this key wording I would like to make some comments please, because right now we are on the stage of let's say starting of production of our second generation of water meters, and this is much more essential because for the past few years of our previous experience with our first generation of devices of smart water meters, it has bring us for huge expertise what we have done worldwide, based on the needs of the utilities and end users, what basically is the main challenges during the installation of big and small projects inside of different global areas. Because like we can see, the water meter segment, it's quite fragmented. It depends from region to region. It depends from utility to utility, the needs, the scope, and not any of the utilities has all the rights to use any communication media, like example, or some accessibility to the installation points where the smart water meters must be installed. Let's try like evolution, and I will name it here like second generation evolution of the previous generation, but basically it brings more than, let's say, more and flexibility, almost no limitation in the power consumption, and no limitation in the connectivity of the devices itself in different areas. This is a key point, and also the evolution of the second generation. It's also evolution during the meter lifetime, where we can bring some new functionalities, where we can adopt the solution based on the needs, and so on and so on. That's right. Basically, right now we are presenting two families of the devices. We can divide them. One family it's integrated water valve, and another one it's without water valve. Again, it's based on the needs and based on the project itself, how it started and how it will be used in the future. In the second generation of meters, we have also just briefly I will introduce a little bit about the sizes, because the line of our families are starting from DN15, DN20, DN25, DN32, DN40, and DN50. We see and with the different length of the pipes with very good and precise meteorological measurements with dynamic range for around 1,600. And also with sensitivity less than 1 liter per hour in case of measurements. What is also important, and also the ultra small and ultra compact design of the meter itself, what was also one of our challenges and key points during the development of our meters. Here I will start. Okay, I will start in more depth about the smallest design meter what we have, because the main challenge was the pipe with 110 millimeters length and DN15, and with integrated water valve. What was the key feature? What we want to put all together in one single combo. What's the benefits of this device, this smart water meter? Of course, this is the usage of the water valve, because in any case it can be activated, close it for 50 processes, close it for 75 processes, for 25 processes, with some limitations. It's also our understanding, and like we see demand from any of the utilities, is that any meter must have the directional control over flow valve, but at any case, at any time, it can be opened or closed based on different conditions. Also, there are some specific systems what we see, like example Italy, like a RERA system, where for some specific customers you have to provide, and you cannot close the water at all, but you have to provide some water during the day based on number of users who are living in apartments, and also such possibilities are just possible when the meter are coming together with a water flow valve, internal one. Another option, this is also like supporting of different prepayment modes, and also again, if you are speaking about the end users, this is some protection in case of some burst of leakage, but also has to be very clearly addressed to the end users as their benefits in case of using a water valve. And we have succeeded to implement everything in one single device, and this is a very small device because it can be easily installed in different locations, different infrastructures, without the need to change them significantly or at all to change them. That's why it's easy just to remove any old meter and to install a new meter with integrated valve, and to have full control under the water, bidirectional control under the flow of water in case if this control is needed. This is the essential part. Even sometimes from beginning it's not needed, but in some future time it's possible to activate and possible to operate with this device using the data centrals. Another key, again, it's one of the measure points as we are speaking here about smart water meter with integrated valve. Operations of a valve, it's requiring some power from the batteries, communications requiring some power from batteries, additional functionalities requiring some power from batteries, and all of this has bring us to the idea to create a device that does not have any limitation at all for any power consumption, and we will be able to work with a device for a huge amount of time until it will be necessary to the utilities. That's why we have decided to prepare a product what has and internal batteries and external batteries. How it works? Let's say we have internal batteries what are mandatory for each of our devices from production phase. This internal batteries has a capacity, it's like a 2C batteries, and it has capacity more than 70,000 milliamps, what's giving the lifetime of a meter more than 16 years. But again, it depends from how it's used, based on what communication technologies we are using in the meters, and how frequently we are operating with the valve. But also it has the possibility to be connected an external power bank, what's placed directly on the meter cover. It's a small one. It's very easy to adopt, to install without the need to remove the meter from the pipe. And it can be added at any moment when it's necessary. But in case if we are speaking technically about procedures, about the logic of an intelligent and adaptive power supply structure, it's things like this. But in case you have a meter with already from beginning installed power bank, the meter is working just from power bank. Just from power bank will be discharged. The meter is switching to his internal batteries, like a two C batteries, and continue his normal operation mode and sending an alarm that the power bank has been discharged. After the C batteries will be discharged, the meter has another internal battery, we name it like a safety battery, who is able to continue his normal operation mode. The meter is calculating the flow normally, storing the data, and local interfaces like NFC and BLE, it's remaining active, but all the remote communication is disabled, just to continue operation from the small battery what is inside. And from this safety battery, the meter can operate more than 1 year. And for in this period of 1 year, the utility will have a possibility to come and to install additional power bank to the meter. And just after the installation of additional power bank, the meter will continue his normal operation with activation of all our communication protocols like NB-IoT, LoRaWAN, wireless bus, and so on and so on. That's when the meter will become normally. And such periodical exchange of power bank doesn't have any limitations. That's why it's possible to do frequently, I don't know, many times. Here I will show you the picture how the meter is showing with power bank and without power bank. From the right side you can see that the meter is without power bank, but it's ready for the connection of power bank in case it will be needed. And from the left side you can see that the meter with installed power bank. It means you don't have to dismount the meter. This is a significant cost of utility to do not expend a lot of money for an installation of a device, because in some countries it's cost much more bigger price than even the meter itself, and it's making a huge economy internally in the business process that are based inside of any of the utility. Also, there is existing possibility to install power bank directly from the factory. It means the meter will be prepared together with power bank and installed to some specific customers. Like example here, we can also, again, to reflect to the valve operations, because we have to understand that if we are installing the water meter to some customers where the valve will be operated frequently, and we can predict this, like example, some prepayment modes or some specific areas where the customers, it's understandable that it's vulnerable customers who will not pay frequently for the water, and there will be, let's say, continuous process of connection, disconnection of the valve. It's better to have already the installation of a meter together with power bank, as to predict the situation that the internal batteries will be discharged during 8 to 10 years, but to prolong it for 15, 16 years, and so on and so on. Like I have mentioned before, there is no limitation of the power bank exchange process during the meter lifetime cycle. Another approach for the also for the limitations what we have saw during the different type of our project implementations, it was the connectivity, because some customers want NB-IoT, and our customers want LoRaWAN, and our customers want wireless bus. Someone wants a mixture of this technology, someone else wants MIT, another one wants WISE. We have decided to build everything in one single combination, but in the meter existing all necessary let's say communication protocols, as customer can decide by himself what type of communication to enable in the meter. It can be done directly from factory, or it can be done later on during the installation phase of the project, because everybody has this knowledge and understand that doesn't exist any technology, communication technology, what's covering 100% coverage in each region. And when we are speaking about water meters, here's coming another limitations, like a water meter installation place, because it can be placed under the ground, it can be placed in different inside of apartments, where the limitation of the coverage can come. And all the time for us it was essential as to provide to the customer not just one single technology, but also some backup technology. And in case of our water meters, it can be, like example, the NB-IoT, it's like a priority communication, and LoRaWAN, it will be like a secondary communication protocol, what can be enabled in case that in some specific area NB-IoT does not have any coverage. Like combinations, any combination, it's possible. It can be, like I have just mentioned it in the previous slides, with LoRaWAN, NB-IoT, wireless and bus, MyIoT, WISE. It can be all together in one single combo, or it can be decided by before the ordering of the devices and project preparation, what type of technology to use in one or another case, as it will be easy and understandable for the customer to select the necessary communication. Like example, here is one of the scenarios, like the project demand, it's NB-IoT, like a primary communication channel. Like a challenge here, we have some places where we don't have any coverage of NB-IoT, and we are going to the GSM provider saying that, okay, I will not install any new antennas inside this area because it's just, let's say, hundreds of devices and so on. For them, it's not. So that's why in this case, the meter will be switched automatically to LoRaWAN communication, like a secondary communication channel. Just in case it will appear again the NB-IoT coverage, where the meter will switch back to the NB-IoT channel. This is done. It's also intelligent and let's say configurable setup. What we can prepare in the meter, like example, when we are starting with NB-IoT, the meter after installation is starting to register an NB-IoT network. If it does not succeed during some predefined time, let's say like 7 days, it doesn't have any coverage, the meter was not registered, then the meter decides that he needs to switch to LoRaWAN channel and starting to register in LoRaWAN channel. If again in LoRa he will be not registered, he is switching to wireless and bus, like example, to the first communication channel what is existing there. If still with wireless and bus he also doesn't have any communication, then he is starting again with NB-IoT, and so on and so on. These scenarios can be multiple of them. Setups can be different because it's easy to set up a device based on different configuration possibilities, and it can be decided with project implementation how we are setting up these devices from beginning of installation. Another important point besides, let's say, remote communication channels, what it's multi-RAT and so on, what any combination like I have mentioned that it's possible. It's also important to mention here local interfaces, what we have in our water meters, because we have decided to limit them on two, but very important channels. One is NFC, what is basically requires some access to the meter and to be prepared and to use some platform like tablet PC or smartphone and so on. And another one, what is more attractive and more essential for in case of maintenance, in case of different scope of bringing to the customer and to the utility different possibilities. It's Bluetooth Low Energy channel, where it does not need and does not require any local access to the device itself, because you can be very, very close, like 5, 10, 15 meters from a device, but you will be able to connect to them under some predefined rules based on the different clients modes and based on the DLMS, some association clients, what will be allowing this communication. Basically, this Bluetooth interface is bringing to the maintenance team a huge advantage that you don't need to come to directly in the apartment in case that the meters are installed in some private area. You do not need to call to the customer that you will come. You're just coming close to his apartment, and you will be able to connect to the device to check if everything is okay and make some maintenance of the meter itself, and to see if everything is running properly, or you have to reset up some meters without the needs to call to the customer to open your door or open your access to a private territory. Another point, what it's also very demanded, like we see from the market, it's like a temperature sensor, it's a pressure sensor, it's firmware updates, it's a different type of protocols what has to be used, and all of this it's also implemented inside of our devices. Can be easily, let's say, set it up, can be easily traced all the information what we are receiving from these sensors with different settings like average pressure, maximum pressure, minimum pressure, and to bring to utility essential information for the proper managing of their water network. I will stop a little bit for the protocols because it's an important one, and we very much appreciate the activities of DLMS UA inside of preparation of generic companion profile. We strongly believe that this is one of the key features for the future, as to have interoperability between the in water sector, because it's very much important. We know this from our experience about the electricity metering, and that's why we are participating in. We are starting to participate in the working groups, already starting implementation of generic companion profile, but also we are not limited just to this, because we understand that it's demanding some 1-2 years until the end utilities and producers of the head-end systems to be prepared for this generic standards companion profiles. That's why we are flexible in different from region to region to adopt our solution in quite fast manner, and to provide the flexibility to the customers to make different data models what are basically let's say will be adopted for their solutions and for their needs. Okay, if in past it was so, of course we have also some other information to speak more, but here I will need to stop and to give a wording to Jonathan.
Good. Well, thank you very much, Maxim. Just before we move into the discussion part, we've got another poll on customer management and billing, and the question is, would you like to offer a mobile app for your customers so they can monitor consumption and become users? And 3 fairly obvious answers. And again, we've got 60 seconds for down to 40 seconds now for your response. And again, let me just remind you that all questions are welcomed, and we'll get through as many of them as we can in the time. Okay, down to 10 seconds. Okay, that's Would you like to start the discussion by commenting on that and perhaps also mentioning the advantages that mobile apps bring both for end users and for utilities? Ruslan or Maxim, who would like to take that?
Yeah, let me comment on that. So thank you very much for this last poll result. To me, it's very, very surprising to receive this result that people are willing to give to consumers the access to their mobile phones, and this is positively surprising because I personally have a smartphone, and we just launched this smartphone application, ultra flow control, to enable consumer control over the meter, to be able to read the meters, to be able to understand our daily consumption, hourly consumption, monthly consumption, because previously we only had the possibility to see our monthly consumption that was on the bills. And we, of course, at ADD Group, I think we are going to be the pioneers in testing this and see how beneficial it is. Besides that, we will have a control over the shutoff valve. This here is, we have to mention that control for the shutoff valve is only given with the permission of the utility. So if the utility permits you to control the valve, so you will be able to do it with your smartphone app. But for me personally, it's very important because let's say in my life, I already suffered 2 times from the flooding in my apartment because of the burst of the pipe, and I really want to protect myself for the future from these bursts and from flooding using shutoff valves. And for example, if I leave for vacation somewhere, I better use my smartphone to switch off the valve and to protect myself from these unpleasant surprises. But definitely one of the biggest positive issues is that people will start to understand more the water consumption profile when you have it on your smartphone. When you just have it on your bill on a monthly basis, it simply doesn't work. You will not start you will not become a reasonable consumer. So the 80%, more than 80%, which would give the consumer this possibility, this is a very, very positive result, and we are happy to see the results of this poll.
I will bring just two more comments, just for understanding, because it's 2 different mobile applications. One is for the end users with some limited access and some reporting about the daily consumption. Maybe it's about the currency, what we can introduce for some, let's say, price of each cubic meter and so on and so on. It means the application for the end users. And another thing, this is a closed application for the maintenance team, who will be able to make more through Bluetooth interface, but also with some commissioning of devices, with some checking of device, and with more control under the specific rules. That's why basically it's 2 applications. One is open one, which will be placed under the Google Store and Apple Store, and another one what will be closed, and it will be decided between the producer and utility under some specific application for the maintenance and commissioning.
Okay, good. Thanks for clarifying that. There are a couple of questions on the connectivity, and the first one is why is G3 hybrid not considered as a solution for the water meters?
Most probably it's because of power consumption, what is used, and another thing, this is the infrastructures what utilities have by this moment. That's why we are following up the let's say the demanding of the projects itself, and basically the demand right now it's the MBIoT and LoRaWAN connectivity, basically, and WISE, of course, and maybe MyIoT, it's also coming faster and faster. This is the reason of selection of the technologies.
And the second one is that the questioner believes that switching from NB-IoT technology to LoRaWAN requires LoRa infrastructure to be deployed, as otherwise the MESA won't be able to communicate via LoRa either. Is that correct? Does this imply that
any technology it's used by the meter, it's required that it's existing media around. But usually it's any of the connectivities it exists. At least if we are speaking about Europe, it's existing for LoRaWAN or NB-IoT. And but in some cases LoRa can have more coverage, in some cases NB can have more coverage. That's why we are bringing an advantage to the customer, that we are providing him the possibility to be connected to both networks. But in any case, we are not providers of the network itself, and in some regions, if we want to switch, at least we have to have the infrastructure behind.
Okay. And then how do you ensure IP68 compliance after connecting an external power source onto a meter which is in operation?
It has such design that after the installation of a power bank, it has a properly done meter cover and power bank. When after the installation of a power bank and ensuring that it was fixed correctly, when we are ensuring the IP68, all our tests and laboratory tests are ensuring this, and we are doing it frequently under some specific time in our laboratories with checking, and but we are sure in IP68 based on the construction of itself of the development of the housing.
Okay, and then in terms of the power source consumption sequence, is the internal or external source consumed first? And do you have any detection systems embedded that can send alerts if any of the batteries are reaching an end?
Okay. Here, when we are speaking about the power sources, when in case if the power bank is connected to the meter, the power bank is discharged first. It's going to power from the just from the power bank. Basically, saying because we have a super cup internally, all the time we are consuming energy just for the super cup. That's why we are protecting the batteries for the normal operation mode in any time. It means we are not jumping from one power to another one. It's all the time it's in the line. And in case power bank is connected, we are consuming first power bank, after this internal batteries, and after this safety battery. In case there is no power bank, when it means we are consuming first main batteries, what is internal one, and after this safety battery. In case of alarming, we are detecting all. In case the power bank will be discharged, we are detecting this and sending a message to the data center and registering it in the meter inside. In case of the main batteries are discharged, we also maintain the, let's say, the level of main batteries and also sending an alarm to the data central. That's why all the time from the top up to bottom, like example, power bank, main batteries, and safety battery.
And can you just mention again the lifetimes? You know, here's, for example, if you've got the basic batteries, if you send one report per day, and how many more years would they last if you use the power bank?
If we are not using the valve, if we are speaking about any communication technology like LoRaWAN or NB-IoT and sending, let's say, the transmission session, it's just once per day, then at least it will be 16 years of a meter lifetime. In case we are sending it more frequently, then we have to calculate how it will be let's say the capacity. But basically, here we have to operate about the capacity of the batteries, because internal capacity of the batteries is more than 16,000 milliamps, and capacity of a power bank is 5,200 milliamps. And based on this, we can do a calculation. But again, in this calculation, we have to bring not only just, let's say, the transmission period. We need also to make calculation based on the region where the meter will be installed, what's the medium temperature, and so on, so on. Let's say any questions about the meter lifetime based on the batteries, you can send to us together with the region based on what we can see the medium temperature inside of this region, and to make for you a proper calculation. We have a specific calculator what can bring some realistic data about the meter lifetime in case of working in different regions.
And are there specific customer groups that one might recommend the power bank for, where perhaps you need greater communication requirements?
Answer this question. So basically, the power bank will be more needed for the situations when the meter has a shut-off valve inside, and the shut-off valve is operated frequently. So in the presentation itself, Maxim referred to the Italian regulation, which is called ARERA regulation, and which basically is dedicated to specific vulnerable customer groups who are receiving the water free of charge, but they are limited in terms of water consumption per day, like 50 liters of water per person per day, which they can get free of charge. And in case they exceed this amount of water, then the valve will close. And this can happen basically on a daily basis. So on a daily basis, the valve will close and reopen the next day. In this situation, when the valve is operated on a such frequent manner, the meter is advised to be ordered with the power bank, or at least the utility has to think that in future they might need to order the power bank at some point of time, after 7-8 years, for example. This is one of the use cases. And the other use case is definitely the prepayment. So our meters support prepayment mode based on STS functionality, and we know that in case of prepayment usage in many countries, especially if we talk about African continent, sometimes they pay only a small amount of money. They purchase a small quantity of water, and let's say which is sufficient for just a couple of days, and then buy more. And in this case, the valve will also have to be operated very frequently. So it is advisable for this customer groups to also have a meter that supports the installation of the power bank to extend the meter life. And with the power bank, with the usage of the power bank, or several, let's say, power banks, when they will be replaced one after another, we can extend the meter life up to 30 years. So the meter electronics will support the 30 years lifetime. We just need to extend the battery life with the help of the power bank.
Okay, now going back to some connectivity questions. In the case of NB-IoT connectivity, the SIM can be assembled by the company, or does it have to be assembled in your factory?
First of all, it depends how customer wish to do this, but we are using eSIMs. That's why basically, if the utility wants to provide the very prepared eSIMs, they have to send it to us, and we will embed it into the meter directly on the factory. There is no any other way. But in case when the utility wants to work with some virtual provider, like once or any hours, what is existing on the market, it's also has the possibility that we can purchase by ourselves once connectivity and provide it to the utility, and it will be working automatically in the network of utilities.
And
is the meter officially certified by the LoRa Alliance, the LoRa WAN functionality?
The previous generation it's already certified, and the actual generation it's under the certification process.
And when is the new water meter with integrated valve going to be available for purchase?
This
head of sales will answer.
In November. So we are at the final stage of getting the MID approval, maybe just a couple of issue, and we're starting the manufacturing of the new water meter next week, actually. So the first meters will be launched into production next week. And basically, for those who want the samples, they can order, and basically by end of November we can ship already the samples, with or without the shut-off valve, with the power bank or without the power bank. So any option. And BIOT LoRaWAN, so maximum version of the meter, will include the NB-IoT, LoRaWAN, wireless and bus, Bluetooth, NFC, and the power bank and the shut-off valve. That's the maximum version of the meter. All in
any of these options what Ruslan has mentioned, excluding the NFC, can be or deleted or handled by meter. It means it's like bricks in Lego. We can add or take something out from.
Yeah, at the moment of ordering.
Okay. And can you briefly explain how BLE and NFC interfaces simplify the installation, setup, and maintenance?
I can quickly explain here. So NFC is the most commonly required interface, but the NFC always requires practically physical touch of the device to the meter. And in many infrastructures, the location of the installed meter is either not very convenient to put a device on top of that, or generally non-accessible. For example, in Republic of Moldova, where we are based, majority of meters are installed inside the apartments, where simply you don't have an access if you don't coordinate that in advance with the consumer. So if at some point of time you need to make some maintenance of the meter, for example, the meter is not online for remote communication, you need to read the meter locally or to change the configuration or whatever, and you simply don't have access to it. So if we have a Bluetooth interface, basically with the help of a smartphone only, or with laptop or tablet PC that has Bluetooth interface, you can access the meter even if it is inside the apartment and the consumer doesn't open the door for you. So for the maintenance purposes and access, local access to the meter, the BLE definitely is a much bigger advantage than NFC.
Also, some few remarks here. It's about the Bluetooth interface, how it's because Ruslan, it's very correctly has mentioned about limitations of NFC, but you need to come to the meter and to have a direct connection to the device. But with Bluetooth, it's also bringing some and more activities. Like example, to make more smarter commissioning of a device during the installation, and it has done some installation of few devices inside of one flat, when you will be able to make the commissioning, to send directly the information to the head-end system directly from your smartphone, and also to bring some essential information for the device, like geographical position of installed meter, and to have, let's say, understanding where the meter is installed based on your location from where you have been connecting from Bluetooth interface to the device. It means it's better and more friendly commissioning of a device during the installation phase, and of course maintenance in the future.
And you mentioned non-revenue water, and can you go into a little bit more detail in how the meters deal with that, both technical and the commercial?
Yeah, okay. So when we talk about the non-revenue water, we have foreseen in our meters additional functionality that can help utilities identify the technical losses, and by means of technical losses we would speak about here the losses before the meter or before the consumer. Here we will have a pressure sensor and temperature sensor and acoustic leakage sensor. So these sensors will generate and create the necessary information for the purpose of further analytics and analysis by the head-end software to understand where the leakage exactly happens. This is from the technical perspective. From commercial perspective, if we deal with the non-revenue water, sometimes it happens that maybe in some countries the people simply remove the meters and start and connect the pipes directly. In order to identify such meter removal, we are using inside the meter the accelerometer, which detects any slight move of the meter from its physical location on the pipe. As soon as the meter has been moved, the accelerometer generates the alarm basically, and the meter reports to the head-end software that there was a manipulation with the meter, and in this case, respectively, the utility has to send someone to check the location. We have seen in a way a similar requirement for the GPS inside the meter, but GPS, unlike accelerometer, is a very power consuming device. This is on the one hand. On the other hand, GPS will not detect the move of the meter if you just remove the meter from the pipe and put it just on the floor. So there is no change of geographical position, and GPS is not detecting that. So GPS will be useless. But accelerometer is very cheap, not power consuming, and reporting any slight change in the position of the meter. This is from the perspective of commercial loss. Another non-revenue water is the water that can be leaked or due to the leakage or burst already on the consumer side. And here, unlike conventional smart meters which do not have valves, the consumer is not protected by the meter. The meter can only generate some alarms that there is leakage or burst detected. In case of our solution with an integrated shut-off valve, the meter can trigger the valve, and the valve will close the water supply in case the leakage or burst is detected. So there is no need for external intervention to close the valve. In this case, the consumer will be protected from leakage, from burst, and from big damages of the flooding, which can be not only to his apartment but also to the neighbors. So this is the way we deal with non-revenue water from technical and commercial perspectives.
Okay, and we're coming up just a couple of minutes to go, and I don't know if one or both of you'd like to give a sort of closing statement, but perhaps sum up what the USPs of your meters are.
Yeah, so the unique sales proposition as of today is basically that one meter can resolve a number of issues. One meter can address the water scarcity issue, and non-revenue water can address the battery life issue and extend the meter life to not to an unlimited period of time, but at least to 30 years at least. And this is the second concern. And the multi-connectivity is also something that we haven't seen on the market yet. So this is also a unique sales proposition, and of course the shut-off valve. Well, there are some companies that also offer shut-off valves to the market, but our unique sales proposition here is that, for example, for the size of the meter DN15, the valve is integrated into the pipe of 110 millimeters. If we look at the, for example, our previous design of the meter, previous generation, then there is a water meter and the valve, and they together they make it like 165 millimeters length. And we met the cases when our customer wanted to install the meter together with the valve, but they simply don't have the enough space to install it. With the water meter with integrated valve, we all have it in 110 millimeters. So this is our unique sales proposition. Nobody else offers that, and this meter can perfectly fit in any space. That's about the USPs.
And just one last sentence: that all the families of the devices you will be able to see on Enlit in next month.
Yes. Yes. So those who
Good. Well,
want,
thank you very much.
November in Bilbao.
Yes, I have to. Good. Well, thank you very much, and thank you very much both to you, our experts, and to our attendees. And just to remind you that the recording of today's webinar will be available on demand on the Enlit World website. And thank you once again.
Thank you, Jonathan.
Thank you so much, everyone, and thanks to the audience for the presence.
Thank you.